GATE 2014 Civil Engineering Set 1 Question 27. A box of weight 100 kN shown in the figure is to be lifted without swinging. If all the forces are coplanar, the magnitude and direction theta and F with respect to x-axis needs to be found. Four options have been given for the force and angle. The relevant NPTEL reference has been listed. So if we are given a body whose weight is W and two forces are acting on the body, let us say this force is T1 and another force is T2. Let us assume this is the x-axis and vertical is the y-axis. Assuming this angle is theta 1 and this angle is theta 2. So now we need to resolve the forces. So the horizontal forces on the body should be 0 for no swing. So this would make T1 cos theta 1 equals T2 cos theta 2. Also the summation of all the vertical forces should be 0. So it would become T1 sin theta 1 plus T2 sin theta 2, which will be the net upward force, and this should be equal to the net downward force, that is W. So using equation 1 and 2, a simple free body diagram of a static body can be resolved and the corresponding variables can be obtained. So in this case, firstly we will resolve all the forces along the y direction and make it to 0. So we can see that this angle is 60 degree. So that would be 90 cos of 60 degree along the vertical, plus we can see that this angle would be 45 degrees. So that would become 40 cos of 45 degrees. Next we will have the force component for F, that is F sin theta, and this should be equal to 100. Using this we would get F sin theta as 100 minus 45 minus 40 over root 2. From this we would get the value of F sin theta as 26.715. Let us call this as equation 1. Next we will resolve all the forces along the x-axis and make it to 0. So on the left side we have 90 cos 30 degree, and this should be equal to 40 cos 45 degree plus F into cos theta. Using this we would have F cos theta as 45 into root 3 minus 40 by root 2. So F cos theta would turn out to be 49.655. Let us call this as equation 2. Now by dividing equation 1 by equation 2, we would get tan theta as 0.538. From this, theta would be obtained as tan inverse of 0.538. That would become 28.28 degrees. Now substituting theta back in equation 1, that is 28.28 equals 26.715. From this we would get F as 26.715 divided by 0.4737, which would be 56.39 kilonewton. That is the magnitude of the force. So the magnitude and direction of the force with respect to x-axis should be 56.39 kilonewton and 28.28 degrees, that is option A. The relevant NPTEL reference has been listed.